Hey guys, welcome back. Today we're going to do a quick follow-up on my InMoov 3D printed robotic arm. Hey guys, welcome back. Really glad you could join me today. Today I thought I'd do a quick follow-up on my robotic arm. Some maintenance I've been meaning to do for some time. For those of you who have followed my channel, you will have seen that I 3D printed this robotic arm. It's called the InMoov. You can print the entire robot, I think, from the waist up at this point. And what I did is I made a brain interface for the Arduino that runs it. And I've hooked this to my brain and affected the output of the arm. I'll post a link to the video here. What I've been meaning to do for some time is get around to the maintenance on this thing. It has worked good, but I never finished off adjusting the ligaments that operate it, and FYI, it is assembled wrong. This wrist is dog-legged the wrong way, and I can't change it without buggering up all the ligaments. So if you don't build yours this way, but a minor amount of problems for what I wanted to do. I want to do a few different interfaces, but the main one was the brain interface. Now I'm up against making it more proportional with the brain interface. You saw in the previous videos that I can do pinch and grasp via my brain waves, but it's not very human-like, and I didn't do a proportional output on the servos that drive. Each one of these is driven by a servo, which is located back here in the arm. I won't take it apart, but you can see them right there. What I never got around to doing was tuning it so that the servos at max extension don't actually overextend. And I think this is a main reason why people burn out these cheap servos, is that they don't actually tune it so that the extension is correct for their setup, because depending on your ligament setup, whether you built the wrist wrong like me, depending on your limiting of the fingers, would set how far you need the servo to travel. Everyone's setup is going to be different, and it takes a little bit of tuning. So today I will show you this. I'll show you what it functions like right now. So this is with the InMoov fired up and running through some rotations, different finger movements. And I don't know if you can hear in the background, but there's a little bit of servo growl at extension, but not much. And this is the key that I was trying to get rid of. None there on those two fingers, and a little bit right now, and it's coming from this this middle finger mainly, which I have a problem with it binding, which is probably mainly due to the wrist that I messed up and a little bit of mess up down here. But let's take a moment and I'll show you how we can fix this. So what I did is quickly I modified the code just to move the middle finger, and you can hear we go to full extension, which this one has a bit of a problem, and why we need to tune it is I can't get full extension on this. I have some binding going on. We don't hear any servo hum when we get to max, meaning we're not cooking the servo. So if I go ahead and change this code back to what I had it, to max extension, and hit upload, I'm willing to bet that we're going to hear what we don't want to hear when we're tuning servos for the InMoov. It's faint, but you'll be able to hear it growling at full extension. And that's what we don't want to hear. So we can do the same with another finger here and give it a try. And that was moving it down 10 steps from a full sweep of 90 down to 80 to make it good, and that's back to 90 again. So that's it, guys. So at the end of the day, what you want is to adjust the max travels so you hear nothing. max extension, max contraction. We don't want to hear the servos growl. That's pretty much it. I think that'll save some people some servos, especially if you're using the 995 cheapies like me. Hope this helps someone. I know it was a bit of a niche video, but if nothing else, we got to play with the InMoov, and now I can move forward to proportional control on my brain interface and my muscle interface, which is coming next. As well, let me pan back a little bit here. If you've watched this long, I have a bit of an exciting announcement. Here are some new parts that I've been 3D printing. There are 7 more bags upstairs, and I think you get an idea of what this is going to be. So I am starting the InMoov head project, the entire skull, eyes, neck assembly. I won't be building, I don't think I'm going to be building the whole InMoov robot, but I think this would be another fun project for interfacing once I finish up with the arm and take it as far as I'm going to go. More videos on that coming up. Anyway guys, thanks for joining me today. Thanks for following along and all your support. Good luck in all your electronics ventures. Drop a comment down below. Share the video. Really appreciated, but more so just appreciate you guys being there and throwing information out. I learned from all of you as well. Thanks guys. One very last note I'll add to this video, just in case someone is actually tuning their servos for a robotic arm out there. What I just discovered, and it seems so intuitive, when I'm using a variable speed servo library, you want to slow the thumb down. You want this guy to be the last guy at the party in any movement except for retract, and he has to be the first guy to leave the party. The guy that drank the tequila. So if you want to pinch, you want the thumb to come over it and not under it. And that way you won't end up conflicting with the fingers on this InMoov arm. Just silly little note. I hope this helps someone. Slow that guy down a little bit on any of the retractions, and leave him full acceleration on the open hand motion, and you'll get something like this, something a lot more reasonable. Pretty happy with this, super happy with the way it's turned out, and yeah, this video is getting really random now, so I'll cut it off here. Thanks guys, really appreciate you joining today.